Ladies and gentlemen, today we will finally be featuring the Sony Trinitron XBR CRT. Here we have the Trinitron XBR logo, and our menu and buttons are actually on the top of this set as opposed to being on the bottom, and that really cleans up this bottom area where you do not have any buttons, and it looks very nice. I really like that. This is a 4x3 display with a 32-inch screen size. Okay, it's the Sony KV32 XBR 45 from November of 1995, 120 volts, 60 hertz, and 195 watts. We have our coax inputs here for RF, and then over here are all the inputs and outputs for composite video and one S-video input. We also have the Sony Control S system available, and we do have an option to input a center speaker to accompany the stereo speakers that are built into this CRT. We're going to test the screen with a Super Nintendo. I've never powered this on since it's been brought into my shop, so let's just see. Okay, we're in VHS mode. Let's press TV video. We are using the S-video input, so this is the best quality it has natively. Here's just a look at the SD to SNES screen. All right, now here's the 240p test suite, and this is very common on some Sony CRTs. You'll see these weird ripples along the edge. Especially these larger CRTs tended to have very poor edge geometry as well as poor convergence along the edges. Well, if we take a quick look at the monoscope pattern for a second, we do have just again some issues, mostly in these corners. We can see a little bit better how bad the convergence is actually separating here. Check out that red. It's definitely way down from the blue and the green in this corner. And if we go along the top edges, that's pretty consistent with how it looks all the way around this top edge. And then the sides get really jagged, and hopefully, some capacitors are kind of worn out and we can improve some of this image, maybe even some of that jaggedness. But even with a full restoration, this CRT is never going to be perfect. I removed the shell, and this thing has not seen daylight in 26.5 years. It is just disgusting, filthy. Look at all that dust and buildup in here. This is going to need an extreme cleaning. If you look down here at our circuit boards, you can, look at the cabling. Woo! Yeah, that's a nice like snow ash buildup right there. It's definitely not from smoke or anything. This is just normal household dust. If it were smoke of any type, as in like cigarettes or pipe tobacco, you'd be able to smell it and it would be much darker and thicker. So the good thing is, since it's just household dust, I should be able to blow the majority of this off with just the air compressor. But this would be our deflection board area down here near our flyback. We need to clean that off. I'd really like to pull this board and get it serviced and also clean it. Just look at how much is built up on this board right here and this board right here. I can't even tell what they're doing because I can't see what they're even supposed to be doing because it's under just an unreal layer of dust. And we'll definitely want to be careful discharging this larger tube. And just look how much nasty stuff, dust is built up back here on this tube. Ugh, gross. Yeah, wow, look at that. Okay, so a lot of cleaning that's got to be done. Yet another reason I do not like working on large CRTs. Things have gotten a little bit cleaner in here, and now we can remove our chassis and all our primary boards. The last thing that's not been disconnected is our anode cap and our anode up here. So we need to go ahead and discharge that. So this is the anode cap. Now look, nobody really needs to use this as any kind of tutorial for how to discharge a CRT. You need to take extreme caution, especially on a large tube. My discharge tool is set up and it is on the main ground loop of the TV. I'm just going to try to use the discharge tool to get under this cap and lift it up so you can see that. And I'm going to just hold the rubber. Let's see if anything happens. Nothing. So even these larger CRTs can have a bleeder resistor built into them and self-discharge. And that was, I mean, like I said, within 20 minutes of us using it, we get no spark from either the cap or from the tube. Now we're back and the XBR has been reassembled and it's obviously a lot cleaner. I've gotten rid of all that dust and I've also serviced some boards in here that I took into my shop. First, our neck board right here, I did recap this and inspect it and test to make sure that everything looked good, especially the solder on some of these points. They get extremely hot because there's a lot of high voltage going through this board. So that board was serviced. If you look at this board right here, this one was recapped. It is the dynamic convergence board actually. So I thought it would be important to recap it to try to have the best convergence possible on this set. Right below that board and in this area are all the deflection capacitors. And I recapped the entire deflection area right in there. That's hard to see, but all those are new capacitors. Now the rest of the boards were cleaned and serviced, but as far as capacitor replacement and parts replacement, that's really all that was needed. There was about 30 bad capacitors. All the rest of the capacitors look to be in good shape and tested out fine. So here's the speakers on this XBR, which are just amazing. You have one speaker here, but then each side has a smaller speaker. And if we look back here closely, there's even a modification where Sony installed a capacitor, a bipolar capacitor right there on one of the lines for the speaker to probably eliminate some kind of buzz or hum. And it is on both of the speakers over here, these smaller ones. Even this side too has that bipolar capacitor. If we take a quick look down here at the deflection yoke, the reason this set suffers from such poor convergence and edge geometry is really due to how steep this angle the back of this tube is. This yoke has to try to push that image all the way up into the top corners of this tube, and it's very difficult with the tube being so flat. Really, to make this better, the tube would need to be longer and that angle would need to come down and be less just straight up and down and more at a slope so that the yoke would be able to perform better. Well, now the Trinitron is reassembled, cleaned up, and we're ready to run just some tests to get some screen demonstrations here for you. Before I hooked it up, I wanted you to see just how much cleaner the CRT is. We've gotten rid of pretty much all the dust and the crevices, and everything's been professionally cleaned. And now we're just ready to plug in some S-Video with stereo audio, and we'll get some gameplay going. First thing, we still have our squiggly line here along the edges even after recapping and adjustment. So that is going to be a characteristic we are not going to get rid of. All right, so the center square here looks pretty good. It's sharp, it's got a nice converged beam. Of course, we're using, again, S-Video. So the sharpness is going to be limited to the ability of S-Video, but on a larger tube like this, that's okay. Some of the areas that are struggling are still our corners up here. This one is better than the others. Not perfect. Now the edges do seem to look a lot better, like in the center of the screen. Both edges look pretty good. If we go down here to this corner, it also has the blue out of alignment, but it's higher this time as opposed to the other side where the blue is lower. If we look at our linearity, it'll show us that our circles are relatively round, mostly round, not 100% round, but maybe over that 92 to 95% round. I want to say thank you everybody for joining me today on this deep dive of the Sony XBR 32-inch television. If you enjoyed the video, please do leave me a like, and if you have any comments, please use the comment zone to your discretion, and I will see you all next time with some more retro content. Oh yeah, and if you just want to hang out for a couple more minutes, I'll play some footage of 240p on this television set.